Welcome back, Hepatic Heroes. In the last video, we talked about the main villain in your hepatic hero journey, which is MASLD, right? Fatty liver disease. And like most villains in comic books and movies and stories, they tend to have their own henchmen, their own minions, if you will, that do their bidding, right? That do the dirty work for them. Gru, for example, from the Despicable Me movies, has his minions. Thanos from the Avengers movies had his Children of Thanos. Darth Vader has his Stormtroopers, and so on and so forth. And MASLD, just like a lot of these villains, has its own minions. And these minions are what allow MASLD to progress as a disease and get stronger. And in this video, we're going to be talking about these MASLD minions that need to be defeated first before you can actually vanquish fatty liver disease once and for all. And I have to stress, this is super important, that in order to make any real progress towards improving your liver health or your metabolic health through nutrition and lifestyle, like I will be showing you over the next few weeks, you must address these 6 minions first, lest your hepatic hero journey may become unsuccessful in the end. So, who are these MASLD minions? There are 6 minions in total that actively work together to worsen your fatty liver disease. And these minions, as you can see here on the screen, there are 6 of them, are based on what's called the multiple parallel hits hypothesis of fatty liver disease, which is currently the best evidence-based theory that helps explain how and why fatty liver disease develops and progresses. And based on that research, I created the 6 minions as an easy and fun way to kind of understand the complex science as to what actually drives, the progression of fatty liver disease. Now, I promise that you're going to learn things that, again, isn't often talked about anywhere else, and that most doctors even don't even know or understand fully. So this is going to be a huge game changer for you. But before we dive into what each minion is and what they do to contribute to fatty liver disease, it's important to note that you don't necessarily have to have all of these issues going on, right? You may have 1 or 2 or several. And if you want a more specific assessment of your particular situation to kind of identify what are the underlying drivers or what minions are at play in your particular case, I recommend that you sign up for a one-on-one consultation with me so I can give you a proper assessment and find out where you're at in this process. The first MASLD minion that I'm going to go over is what I call rogue cells, and specifically rogue fat cells. Now, as you can see here on screen, this kitty has normal looking cells. This is a kind of like a zoomed in picture of the fat cells of this cat, right? Now, as you can see, these cells are normal size. They're not too big, not too small. They have plenty of space in between them. They're functioning normally. They're getting the nutrients and the oxygen and the resources that they need, right? These are normal cells. But what happens when these cells start to go rogue? Well, as we start to gain weight and as these fat cells start to grow, and this is especially true if you are overweight or clinically obese, not so much if you're experiencing lean NAFLD. However, this still applies to you because fat cells still go rogue in those cases as well. But especially if you're overweight, as you start to gain weight, well, what happens? Well, these fat cells start to grow, right? They start to store more fat and they get bigger and they get bigger and they get bigger. Now, there's a certain point where the fat cells in our body get so big that they start to rub against each other, right? They start to get too close to each other. They start to run out of space. If you think of yourself in a bus, right, and you're traveling down this bus, and after every bus stop, more and more people get into the bus and no one gets out. At some point, the bus is going to get so tightly packed with people that you're going to get crushed. You're going to suffocate. You're not going to be able to move. And eventually, if enough people join the bus, you'll die, right? Well, a very similar thing happens with your fat cells. As these fat cells grow and grow and grow because of our diet, our poor diet, high in processed foods, sugar, a ton of saturated fat, etc., they start to get too large and they start to take up all this room and they actually start to suffocate themselves because now oxygen can't properly travel into the cells and into the nucleus to keep it going and keep it functioning properly. And what ends up happening is that they start to become damaged because of the lack of nutrients getting into the cells, because of the mechanical pressure being compacted up against all these other cells. And what ends up happening is this is super important. As your fat cells become damaged because they're too big and they have too much stress upon them, they start to secrete 3 different things. Several things in reality, but 3 different things that pertain to MASLD in particular. One is they start to secrete the fat that they store, right? Because they're trying to get rid of some of the fat as much as possible to kind of shrink as best as they can. They'll also start to secrete inflammatory cytokines or inflammatory chemicals, which is represented by this little fireball chemical here, right? Now, these inflammatory chemicals signal to the immune system that there's something wrong, that these fat cells are becoming damaged because of all of the issues that we just mentioned, and it'll start to attract the immune system to come and deal with them. And what that really means is that the immune system will come to basically destroy these fat cells. Now, so they'll start to secrete that, and they'll also start to secrete any chemicals that they have stored within them, because as we're exposed to pollutants, like the chemicals in our cleaning products, cosmetic products, the pollution in the air that we breathe in, well, a lot of these chemicals get absorbed into our body, and guess what? They can't be floating around our bloodstream. They're going to start doing a bunch of damage to our body. And so one of the things that our body can do is take them out of circulation, store them into fat, because a lot of these chemicals, these harmful toxic chemicals, are fat soluble, or they have a certain affinity to fat, which allows them to be attracted and stored within fat cells, so that we kind of get rid of the problem temporarily. But in this particular case, since there's a ton of damage occurring within the fat cells, and there's a ton of dysregulation and dysfunction, they'll start to release that as well into the bloodstream. Now, this is a big problem, because what'll happen then is that as these get secreted by your fat cells, by your enlarged fat cells, which are found throughout your entire body, mainly around your abdomen, your thighs, etc., right? The places that tend to grow as we gain weight. Well, all these fat cells will start to secrete all of these things, the fat, the inflammatory chemicals, and any toxic pollutants that we have stored into your bloodstream, right? And as this is happening, guess where that bloodstream and guess where all of these things are going to travel to? Well, they're going to travel to all over your body, but in particular your liver, are they not? Because all blood flow eventually has to go through the liver to be filtered. But they'll also travel to your muscle cells, for example. They'll travel to other organs in your body, like for example, your pancreas, like we have here, and of course other fat cells as well. And they'll start to dump all this excess fat, these inflammatory chemicals, these toxic pollutants through all these tissues in your body, but of course, in particular, since we are talking about MASLD, into your liver. And guess what happens? Your liver is going to absorb these things, because your liver is trying to filter your blood, your liver is trying to pull things out that aren't supposed to be there, like this excess fat, like these inflammatory chemicals, like these pollutants, and so on and so forth. And what this will do systemically throughout your body is it'll increase your level of insulin resistance, for one. The other thing that's going to do, it's going to increase your liver inflammation, because all this stuff is going to go into your liver. It's going to start causing all this damage and then trigger an inflammatory response. And as we talked about in the last video, when you have an inflammatory response and we start to trigger what's called NASH or MASH, then that becomes a driver of liver damage and eventually fibrosis, right? So this is a big deal, because we're getting systemic inflammation at this point being poured into our bloodstream through our fat cells that eventually travel into our liver and get absorbed there and start to cause damage. Now, here's the interesting tidbit. A lot of the fat that ends up in your liver is actually coming from this process. A lot of people think and believe that dietary fat, the fat that we eat, is the major source of the fat that goes into our liver. In fact, a lot of doctors still believe this as well. But there's actually a study that was done where they actually measured like where the fat was coming from. And it turns out that 60%, at least in this particular study, by Donnelly et al., and I'll reference it at the end of the lesson, in this particular study, it showed that about 60% of the fat that ends up in the liver actually comes from this process. And only about 15% of the fat that shows up in the liver comes from dietary fat, or the fat that we're actually consuming or eating. So this is a big contributor to MASLD and its progression. Obviously, cholesterol and triglycerides will rise, and of course, oxidative stress will also be rampant all over the body. The next MASLD minion are the signal jammers. Now, this is super important. I mean, they're all important, but this is really important, because signal jammers, when we're talking about signal jammers, we're talking about things that disrupt the communication system in your body. And what that means is the hormone system, right? We're talking about hormone miscommunication. When there's hormone miscommunication that occurs in your body, it causes just chaos in every single system, every single organ, every single tissue, but in particular, your liver. And to illustrate this, we're going to use the pancreas as an example. Now, the pancreas is an organ that secretes a hormone called insulin, which most people know and are aware of. Now, insulin, again, it's a hormone. Hormones are chemical messengers that basically communicate something to other cells to do a particular thing, right? And the normal process of hormone communication is that an endocrine gland, like the pancreas, will secrete insulin, which will then travel throughout your entire body, through your bloodstream, and eventually hit and attach to the different cells in your body in order for insulin to tell it to do a certain thing. In this case, insulin tells your cells to open up their doors to pull in glucose from the bloodstream and into themselves, so that it pulls the glucose out, and so that they have the glucose now to actually produce energy, right? So that's the basic gist of hormone communication. Now, what happens in MASLD and what happens with signal jammers is that something happens that interrupts the process of either the production of hormones by your endocrine glands or the reception of hormones by your cells, right? That communication gets disrupted and gets ruined, basically, and therefore the message doesn't get to those cells to do the things that they're supposed to be doing. Now, some common hormones that are interrupted in MASLD in particular. Now, there's a bunch of hormones that can go out of whack, but these are some of the common ones, right? For example, insulin and glucagon from the pancreas, right? Often get interrupted. GLP-1 secretion from the intestines also often gets interrupted in MASLD. Thyroid hormone from the thyroid gland, which is this gland over here,
Also gets interrupted. For those of you that are hypothyroid, you know this. Leptin, adiponectin from fat cells, because we just learned that fat cells kind of go rogue, right? And they become dysfunctional. Corticosteroids from adrenal glands, testosterone, estrogen, et cetera, et cetera. Now, you don't need to know the particulars about this. The point that I'm trying to make here is that when MASLD occurs, when these minions are going out of control, it's not just affecting your liver. The thing about fatty liver disease is that it's so related to other parts of your body and your organ systems and your biology that when the liver starts to become dysfunctional, everything else tends to go haywire as well. And I want you to understand that and know that, because this is why a lot of people with fatty liver disease also end up having things like PCOS in women, obesity, diabetes, cardiovascular disease, hypothyroidism, gut issues, fertility issues, reproductive issues. A lot of men with fatty liver disease tend to develop prostate issues because of testosterone, the hormone testosterone dysregulation that happens there. So I want you just to understand that all sorts of things can go haywire from a communication standpoint because of these signal jammers. So how does the signal jamming actually take place? So if we go back to our pancreas example, the pancreas is supposed to secrete insulin, this hormone. It goes into the bloodstream, it reaches the cells. And what's supposed to happen here is that the hormones are supposed to bind to different receptor sites on the surface of the cell so that the cell can then respond to that and then do the thing that the insulin tells it to do, right? And this is kind of the normal function that's supposed to happen with any hormone, not just insulin, but in any hormone that your body produces. Now, what happens is that a few different things can actually interrupt this signal or this communication. In other words, there are signal jammers that can come in and disrupt this process. The first one is nutrient deficiency or excess. If you don't have enough of a particular nutrient, if you're deficient in iron or B vitamins or any other micronutrient, well, guess what? The cells in your pancreas that are responsible for producing insulin may not have the nutrition that it needs in order to actually produce the insulin. Right? And this applies to any other endocrine organ that produces a hormone. So that can screw it up. Too much of a particular nutrient. For example, if you're eating too much sugar, well, guess what? Sugar in very high amounts over a long period of time has been shown to force the pancreas to produce more and more insulin all the time because it doesn't have a way to stop doing that. And so as long as there's a ton of glucose and sugar floating around, your pancreas is going to produce a ton of insulin. And therefore, at some point, they could even become exhausted and damage those particular cells, like in the case of advanced diabetes. On the receptor side, nutrient deficiencies or nutrient excess can interrupt the signaling process of the receptor sites of the cells. Inflammation is another big one. We just talked about in the rogue fat cells that with people with fatty liver disease tend to have a huge amount of inflammation floating around your body. Inflammation can both damage the endocrine gland, in this case the pancreas, and actually bind and disrupt the communication at the receptor site of cells. So that's another way. Gut dysbiosis, again, will trigger inflammation. Endocrine disruptors like pollutants from cleaning products, cosmetic products, environmental pollutions can act as endocrine disruptors, meaning that they'll disrupt either the production or the reception. Medications can do this. Genetic mutations can do this as well. And as we go through the phases, we'll talk about the specific nutrition strategies in order to improve this and to undo some of the damage that is caused here. The third MASLD minion is the invaders. All right, the invaders are really, really interesting subject. So when we talk about the invaders, we're talking about your gut. We're talking about your gut health, your small intestine and large intestine health, primarily. Now, if we were to zoom in to your intestine, right? As you can see here, this would be the inside of the intestine, in case you don't know. This will be the outside of the intestine. This will be the inner lining of the intestine itself with the enterocytes or your intestinal cells. And then we have the outer layer. And then out here will be your bloodstream, which will then travel to the rest of your body. Now, under normal circumstances, as you can see here, the enterocytes or the cells that line the inside of your gut are usually tightly packed, right? And they act like a barrier, which selectively allows certain things to come into your circulation and more importantly, prevent a lot of things from not going in. One of the things that it prevents from actually entering or passing this membrane layer is things like bacteria, viruses, any other kind of chemicals or anything that's not supposed to be inside your body, right? Now, here's the problem. A lot of people with MASLD tend to have a compromised gut, tend to have damage in this inner lining here. And it looks more like this section right here that we have here. As you can see here, there's more spacing in between the intestinal cells. And this is a big problem because now anything that's floating around in your intestine that is normally toxic can now enter your bloodstream, right? Big problem. Because when things bypass your intestinal wall, like bacteria, for example, or viruses or any other toxic substance that's not supposed to actually enter your body, guess one of the first places that it's going to travel to? In fact, the first place. It's going to be your liver because all the blood flow that goes from your intestines has to go through your liver first. When it travels to your liver, when you get all this bacterial toxicity, things like lipopolysaccharides and a bunch of other stuff that causes a ton of damage, enters your liver, guess what happens? Your liver gets hammered. It's hammered by this. So much so that it's going to trigger a ton of inflammation. It's going to trigger liver damage, right? Because as we know, as we learned, liver inflammation means the progression of fatty liver disease into fibrosis and beyond. And more importantly, check this out. The literature demonstrates so far that this by itself, this issue with the leaky gut, right? Your leaky gut or dysbiotic gut or intestinal permeability, whatever you want to call it, this issue with the invaders by itself can cause fatty liver disease. Meaning that you don't even have to be overweight, you don't have to have insulin resistance, you don't have to have rogue fat cells or anything like that. This by itself can cause and progress fatty liver disease. This is how important and how significant this MASLD minion is. And throughout this course, we're going to do work towards fixing and improving your gut health as part of the overall strategy in your hepatic hero journey. The next MASLD minion is the Pyromaniacs. Now, the Pyromaniacs are really important. When we talk about Pyromaniacs, we are talking about your immune cells, right? And your immune system. Inflammation, right? We know by now that inflammation is a big part of the progression of MASLD. But how do these Pyromaniacs serve as minions to the main villain, which would be fatty liver disease? Well, as we continue to have dysfunction in your fat cells and your rogue fat cells, as we continue to have signal jammers disrupting our hormonal communication, as our gut health deteriorates, what tends to happen is that cells throughout your entire body become damaged. Okay, when cells become damaged, especially in your liver, because at this point your liver is incurring damage, what happens is that these damaged cells will start to secrete inflammatory chemicals, right? Just like how the fat cells do. But this is happening in your liver, this is happening throughout your body in different tissues. When this happens, when damaged cells secrete these inflammatory chemicals, these chemical messengers, what they're doing is that they're calling for help. They're saying, we have a problem, I'm broken, the guy next to me is dead, the guy next to me is super beat up, we can't function as cells anymore. And when that happens, they call in the cavalry, right? And the cavalry is your immune cells. And the immune cells are responsible for coming in and basically either getting rid of what's causing the damage, if it's a bacterial infection or anything like that, or destroying the dysfunctional cells because those cells cannot function as a normal healthy cell anymore. And so they have to be getting rid of. Otherwise, they'll start to damage all the other cells around them, and your immune system will not allow this. So they're going to go in and destroy these cells, which is part of the reason why your liver gets so jacked up when there's a ton of inflammation, because the cavalry is being called in all the time and they're wreaking havoc. They're starting to damage all of the tissues within your liver. Now, how does this work out? How does this play out? So we have dysfunctional fat cells, we have dysfunctional muscle cells, your gut health. All these cells are starting to kind of become dysfunctional and damaged. As soon as that happens, these damaged cells will start to secrete their inflammatory chemicals, right? And just like the rogue cells, the rogue fat cells, these inflammatory chemicals, well, guess what? They're going to start being secreted into your bloodstream, right? And we're talking about our muscle cells, right? We're talking about our fat cells. Most of our body is muscle, are these tissues. And so you're getting this constant dump of inflammatory chemicals throughout your entire body, kind of nonstop. And it's all entering your bloodstream again and again, like we've talked about before. Anything that goes to your blood ends up in your liver, right? And when you have all these inflammatory chemical messengers that are in your liver, well, guess what's going to happen? They're going to attract the immune cells over there, right? They're gonna travel to these places and they're gonna start doing their thing. They're gonna start damaging whatever's around them that has been tagged as dysfunctional or damaged. And when that happens, of course, you get an increase in liver inflammation and damage, but you also it starts to progress the disease. You'll start to enter things like NASH and MASH more quickly, and then you're on and off, right? You're on and off on the road to fibrosis and beyond. Now, some triggers of inflammation, some triggers of these pyromaniacs, right? Of these minions, these pyromaniac minions are things like poor nutrition, high amounts of sugar, high amounts of saturated fat, high amounts of processed food are all well documented and known triggers of inflammation that happens all over your body. Poor sleep will also do it. High stress will also do it, especially if you have high levels of cortisol. That triggers inflammation. Lack of exercise. Of course, if you have any genetic predispositions, that's not going to work in your favor. A toxic environment, if you have excess toxicity because you're exposed to a bunch of environmental pollutants, that'll also trigger immune response because those environmental pollutants will damage cells. And so therefore, the cavalry will be called in. Or again, like we talked about, hormonal dysfunction and of course, cellular dysfunction. And these are the pyromaniacs. And as you go through the phases and as you go through the trainings, you're going to learn how to eat and work out and live in a way that will reduce the inflammation in your body as much as possible. The next minion is the supply disruptors. Now, when we talk about supply disruptors, we're talking about nutrient deficiencies, right? We're talking about anything that'll prevent your body to transport or to absorb vitamins, minerals, any other micronutrients that are needed in order for your cells
to absorb them and thrive and stay healthy. Because if your cells are not getting the nutrients that they need, then those cells will become dysfunctional. And when those cells become dysfunctional, they will eventually become damaged. And when they become damaged, like we just talked about, they're going to start to secrete these inflammatory chemicals, call in the cavalry of your immune system, and then progress the disease by encouraging inflammation and causing this damage, which will then occur all over the place and eventually reach your liver, right? So what are the common supply disruptors? Now, this is by no means a comprehensive list. There's a lot to this, but here are some common ones that are typically found in those with MASLD or metabolic dysfunction in general. So what are some of these supply disruptors, right? The first one is nutrient deficiencies, meaning that you're just not consuming enough of the nutrient. The biggest nutrient deficiency, or at least the most common one that contributes to MASLD, because we're talking about MASLD here, is choline deficiency. Choline deficiency is a big deal because the literature shows that by itself, if you're just choline deficient, then that itself is enough to trigger the development of fatty liver disease, irrespective of anything else. So it's a big deal. It's a big deal. Micronutrients, such as minerals like magnesium, iron, zinc, are also largely found to be deficient in many people with MASLD. Vitamins as well, especially vitamin B, vitamin D, vitamin C, have been shown to be deficient in MASLD patients and fatty liver disease patients as well. But also nutrient excesses, like if you're consuming too much sugar, right, too much glucose, and you're constantly hyperglycemic, you're constantly driving up your blood sugar levels. Well, high blood sugar can also use up your magnesium, right? And result in less magnesium being available for your cells to function properly. So that is the first nutrient deficiency. The next common supply disruptor is anemias. If you are anemic, that is a big one, especially if you're a woman, because a lot of women with MASLD tend to be anemic as well. Now, there's several types of anemia. It's not just about iron deficiency. There's also vitamin B6 deficiency anemia. There's anemias related to infection because your body will try to reduce the amount of circulating iron to combat infection because bacteria and viruses love to eat iron to multiply. So there's many different ways why, or many different reasons why you can be anemic. Now, anemia is important because if you're anemic, you can't transport oxygen to your cells properly. And your cells need oxygen in the form of molecular oxygen. We're not talking about like the oxygen that we breathe, but molecular oxygen. They need that type of oxygen in order to produce energy within the mitochondria. If you don't have enough oxygen because you're anemic, you're not going to be producing enough energy in your cells. If your cells don't have enough energy to run itself, then they become damaged. They eventually get destroyed, dysfunctional, and then again, it'll trigger inflammation and off we go. The next one is antioxidant deficiency, meaning that you don't have enough antioxidants floating around in your body to combat the oxidative stress that happens when you have a fatty liver, because a fatty liver produces a ton of oxidative stress for a bunch of different reasons. So things like vitamin E deficiency. Vitamin E, I think, I was reading a paper, is actually the one of the vitamins that people are most deficient in, which is pretty interesting. And if you look at studies that measure the amount of vitamin E in people with fatty liver disease, they're among the lowest because vitamin E is such an important antioxidant. Some papers even say that it's the only true antioxidant for a bunch of different reasons. Glutathione deficiency. Guess where glutathione is produced? You know, we all have heard about glutathione, like the master antioxidant. Guess where it's produced? In your liver. If you have a fatty liver, you have a dysfunctional liver. And guess what? Your dysfunctional liver probably isn't producing enough glutathione. And the thing about glutathione, it's not just only important for combating oxidative stress, it's also super important for detoxification, phase 2 detoxification to be precise. The glutathione is important in that process. And if you don't have enough of it or you're not producing enough of it, then again, you're going to have a lot of oxidative stress, a lot of damage. Your ability to detox through your liver is going to be a lot less, and it's going to cause more problems. And then finally, the last one that I want to mention is mitochondrial dysfunction. So a lot of people understand the mitochondria. And if you don't know what the mitochondria is, it's an organelle. And an organelle is basically an organ within your cells, just like how we have a heart and a liver and a kidneys and all that. Well, your cells also have like mini versions of organs, and these are called organelles. And one of those organelles is your mitochondria. Now, most people understand the mitochondria, which I've actually kind of zoomed out here. Right? It's this little pink thing that I've blew up here. Now, most people understand the mitochondria to be the powerhouse of the cell, which it's true. It does produce the energy that your cells need in every cell, almost every cell in your body, with the exception of red blood cells, in order to keep the lights on, in order to keep producing the energy so that things keep, stay alive and stay functioning. It's also involved in producing oxidative stress, especially in your liver, because one of the things that your mitochondria can do is that it can use fat and burn fat and turn it into fuel. But when it does that, it'll also produce a lot of oxidative free radicals, right, which cause the oxidative stress. It's very similar to when we burn gas in a car engine. Yes, we get to burn the gas and we produce the energy that allows the car to run. But as a result, we also end up producing a lot of CO2, right, as a result of the reaction. Same thing happens here when your mitochondria starts to
burn through fat, especially in your liver, because again, you have a fatty liver. There's a ton of fat everywhere. When your mitochondria starts to take in all this fat, starts to burn it up to try to get rid of it, it'll also produce as a byproduct free radicals, which will then increase your chances of oxidative stress, right? So big problem with the mitochondria. Also, the mitochondria, when it's overwhelmed and it's damaged, and when it starts to sense that the cell is damaged, especially your liver cells, it actually has the ability to trigger cell death, also known as apoptosis. Another important factor, because if you have a ton of dysfunctional cells within your liver and the mitochondria are completely and totally overwhelmed, then they're more likely to trigger cell death, which will then destroy the liver cells, which will then cause your immune system to come in and get rid of that, will cause your liver to lay down some more scar tissue and fibrosis. And if this is constantly happening over and over again, well, guess what? You're on your way to fibrosis. And again, I know I've said this already, but as you go through the phases and as you learn the specific nutrition strategies and supplement strategies, in case you need to supplement some of this stuff, you will learn how to address these supply disruptors and get rid of this MASLD minion that is wreaking all this havoc. The last MASLD minion are the Saboteurs. Now, the Saboteurs are a fascinating subject that the literature is just starting to scratch the surface on. But when we talk about the Saboteurs, as you can see here in the graphic, we are talking about genetic mutations, right? Genetic polymorphisms, as they're typically called at least in the scientific literature. Now, normally, if you ever watch a movie, a superhero movie or a comic book, normally genetic mutations result in gaining super cool new mutant superpowers, right? But in the case of MASLD and many other metabolic illnesses, genetic mutations unfortunately make our bodies more vulnerable to developing disease, which is kind of a bummer because I wish I would just get the superpowers instead. And I'm sure many of you would agree. Now, these genetic mutations are a problem. They're a big problem because any major changes in our DNA and how that mutated DNA is expressed will result in changes in how our cells build and produce proteins, right? For example, you see a 3D model of a protein here on screen. Now, proteins are made in your cells through your nucleus, which houses your DNA. And your DNA basically provides the recipe book, if you will, and the instructions on how to build these specific proteins, which can become enzymes, hormones, structural proteins that actually build the structure of the cell, etc., and so on. And you can look at these proteins as sort of the Lego building blocks of life, basically, on a cellular level. And if these Lego pieces come out defective in any way because of a genetic mutation, because there's an alteration in the recipe book of your DNA, if you will, then the structure of your cells, the structure of your hormones, your enzymes, which are all proteins, by the way, will be slightly defective and therefore will lose their function or will not be as functional, because the function of a protein relies on its specific shape and how it's physically arranged. And so if you have certain genetic mutations for different proteins that are found in your liver, or different proteins that control your glucose metabolism, or the production of certain hormones, then you can see how these mutations can contribute and set you up to be more vulnerable to developing certain diseases like MASLD. Now, the top genetic mutations that are known so far that relate to MASLD and the progression of fatty liver disease are listed here. Now, just so you know, this is a very short list. There are several, and there's going to be several more as the literature and studies kind of keep discovering these and their involvement. But these are kind of the top 4 that are often cited in the literature and have the most research to back them up. And you can read through these. The most common one, or the most talked about one, I should say, is PNPLA3, which causes things like the accumulation of triglycerides in your liver cells. It depletes your polyunsaturated fat levels, right? Your good fat levels, your healthy fat, anti-inflammatory fat, right? It decreases that. It increases inflammation in the liver, and it actually progresses or supports every single stage of the disease, right? And then you have the TM6SF2, decreases the liver's ability to remove fat from itself, and so on and so forth. All these genetic polymorphisms and mutations will screw up your metabolic health in some way that'll contribute to you developing fatty liver disease more easily, especially if you're not taking care of your diet, nutrition, and lifestyle. In addition to that, I also have some information as to what ethnic populations are at a higher risk of having these particular genetic mutations. And this is pretty interesting. There's still not a whole lot of studies, but the studies that do exist put the Hispanic and Latino populations at the highest risk of developing these mutations at 43%, right? Almost half, right? So if you're Hispanic or of Latino descent, then you almost have a 50-50 chance of having these genetic mutations, and therefore you should be extra careful with your nutrition, your diet, and your lifestyle. Next after that is the Asians, people of Asia or Asian descent at 37%. East Asians, those of like Indian or Pakistani origin or that region of the world, they typically have a high risk of having these genetic mutations. And they particularly, for whatever reason, have a high risk of developing what's called lean MASLD, meaning that they're not necessarily overweight. They could be quote unquote skinny fat, as they, some people describe it, and still have MASLD. And then of course you have the Europeans at 26, Native Hawaiians, less than 10%. African Americans are also less than 10%. Well, then your next question should be, Dr. Herrera, that's great that my genetics are all screwed up. Can these mutations be reversed, or can anything be done to improve them? And that's a great question. I'm glad you asked. Well, it turns out that mutations, right, DNA genetic mutations cannot be reversed per se, right? But their expression, meaning whether or not they get turned on and activated and actually be used to produce proteins and be used in the sort of recipe to make these proteins, that can be turned off or on, right? And this process of turning off, so to speak, and turning on the expression of these genes is called epigenetics. And many of you have probably heard of epigenetics, or the field where we study the effects of our environment on whether or not these genes get expressed or not. But for those of you that aren't familiar, epigenetics is basically the science of and the study of how genes get expressed or get turned on or off by environmental factors through a process called methylation. Now, you don't really need to know what methylation is or the complexities of it, but in a nutshell, if there is high methylation around these genes, then these genes can be turned off. If there is low methylation, then these genes can be turned on, right? So that's kind of the basic idea and gist there. Now, let's define environment, right? Because what does it mean for our environment to influence whether certain genes get expressed or not? Well, environment means the food that we eat, right? Our lifestyle, the toxicity and the pollution in our environment that we're exposed to, our stress level, our medications, any comorbidities or diseases that we have, and anything like that, right? Anything in our environment that is actually more or less under our control. These things we can take into our hands and alter and modify so that we can use them to our advantage to turn certain bad genes off and maybe turn certain good genes on. A little more complicated than that, but that's kind of the basic gist, in order to decrease the chances of these genetics, these faulty genetics, from causing us illness in the future. So what can we do about it? What can we do to take control of our environment so that it works for us and not against us in promoting a more favorable gene expression, if you will, so that we don't, basically don't get screwed genetically? Well, it was actually kind of tricky to find studies and information in the scientific literature that kind of measured the specific foods or nutrition patterns or dietary patterns in MASLD subjects that related to these specific genes. Like, there wasn't any like MASLD specific studies, but I was able to find other studies where they tested certain nutrients and then checked to see what happened to their genetics and what got expressed or not expressed. And using some of the more indirect studies like that, I managed to put together and identify some patterns, right, that relate to people with MASLD. So let's start with things that trigger unfavorable gene expression in MASLD, right? So these are the things in our environment that'll increase the chances of us activating these more harmful genes that will then make us sicker. The first one, and this should be no surprise, is Western diets, excessive in fat and sugar consumption. Right across the board, if you look this up at all, you'll find that overwhelmingly any kind of Western diet, high in fat, high in sugar, high in processed food, will trigger unfavorable gene expression. Overconsumption of calories, eating too many calories, can also do this. High fructose consumption, especially high fructose corn syrup, will also do it. And again, this shouldn't be any surprise because these are all the things that we've heard contributes to fatty liver disease. So it makes sense that these will also contribute to the more unfavorable gene expressions that will then, allow fatty liver disease to more easily develop. Also, nutrient deficiencies in folate, vitamin B9, again, choline, betaine, methionine consumption has also been linked to these unfavorable gene expressions, which makes sense because a lot of these, especially choline and methionine, are methyl group donors. And if you remember, high methylation means that we turn off these more harmful genes, right? So if you're not eating enough foods that have methyl groups or methyl donors that'll increase methylation, then the chances of you expressing these more harmful genetics is going to be higher. So deficiencies in choline and methionine, it makes sense. And of course, alcohol and tobacco consumption will also not help for many different reasons. That should be pretty obvious. Now, things that trigger favorable gene expression in MASLD, according to the literature, and this is a short list, there's going to be more, but diets rich in folate and choline, obviously betaine, methionine, will obviously prevent liver fat buildup for reasons that I just mentioned. Polyphenols from olives, fruits, and veggies. Polyphenols are these special chemicals that are found in vegetables and in fruits that have a ton of health benefits. These can help modulate gene expression in your favor. Mono and polyunsaturated fats, or the healthier fats from fish oil, olive oil, nuts and seeds, etc., also help. Energy restricted and hypocaloric diets. So if you, for example, use fasting or
eat a hypocaloric diet where you're eating maybe 500 calories less than what you're used to. That'll also, it seems to also promote the favorable expression of healthy genetics. The ketogenic diet, especially the very low calorie ketogenic diet of 800 calories or less, has shown to be pretty good at improving this genetic factor. And then we have weight loss and exercise, which have also been shown to support in healthy gene expression. Congratulations, you are done. You just learned about all of the 6 MASLD minions that contribute to fatty liver disease. Congratulations, that is no small feat. You now know and understand more about fatty liver disease and MASLD than most doctors do. So pat yourself on the back. You have done a great job. This is going to go a long way. The cool thing about all of this is that you just have to learn this information once so that you know in the back of your head, more or less, what you're doing and what you're addressing as you go through the different phases of the Hepatic Hero community and you apply all the nutrition principles, all of the lifestyle principles, how to exercise correctly, how to do everything that I'm going to show you and teach you. You're going to know this at a very fundamental level, which means that you'll know it for the rest of your life. And no one's ever going to be able to take that away from you. So awesome. Congratulations. You learned about the rogue cells, the signal jammers, the invaders, the pyromaniacs, the supply disruptors, and the saboteurs. And in the next phases, you're going to learn how to defeat each and every one of these. And you're going to succeed as long as you do the work and as long as you apply everything that I'm going to show you. And by doing so, you will vanquish the main villain in your Hepatic Heroes story and improve your liver health, and as well as vanquishing all of the MASLD minions that we just talked about by applying everything that we will show you. Also, while being supported by our awesome community here at Hepatic Heroes. Together, we will achieve success. So that is it for this introduction. From here on out, in phase 1 and beyond, we will just focus on the simple, easy, step-by-step process that you need to do and you need to take in order to start improving your liver health, to start improving your nutrition, your sleep, your exercise, your lifestyle, everything that we need to do in order to address all of the issues we just mentioned. So congratulations. I can't wait to see you in phase 1. Make sure that you post actively in the community, get those points, level up, grow in our community, and become and achieve the Hepatic Hero status that you were meant to achieve. Thank you, and I will speak to you in the next lesson.